Two particles have these masses. They're attached to the ends of a string and they're hanging freely. And the string passes over a small, smooth pulley, and they're initially 1 meter above the floor. So let's draw ourselves a quick diagram. So here's A, here's B. Um, 0.4g here and 0.3g here. And we can draw T here and T here. And without reading the rest of the question, we can figure out what the acceleration of the system is. So I'll do that here. So for A, we've got 0.4g minus t equals 0.4a. And for B, we've got t minus 0.3g equals 0.3a. If we add these two together, we get 0.4g minus 0.3g, 0.1g, equals 0.7a. So a equals 1 over 7g. Um, so it says they're released from rest and the string breaks after 0.5 seconds. So let's do a suvat to figure out what happens, or what the situation is after the string breaks, or as the string breaks. So we know that u is 0 because we're releasing it from rest. We know that t is 0.5, which I'll write as a half. And we know that a is 1 over 7g. So that means v equals u plus at. So v is just 1 over 14g. And s equals ut plus a half at squared. So that's going to be t squared is 1/4. 1/4. And a half a is 1 over 14g. So that's going to be 1 over 14 times 4g. And I'll just do that on my calculator to see whether it's nice. So 9.8 over 14 over 4. And that gives S is 0.175 as the displacement. We want to find the additional time taken for B to hit the floor. So this is before the break. After the break, SUVAT, we can look at B. And what I'm going to do is I'm going to look at down as positive. And the reason I'm doing that is because the distance B needs to travel is down, and so is acceleration. So two of my three values are going down. So if I do down as positive, I'll have more positive values than negative values. So after the break, B is just in free fall. There's no other forces on it. So A equals G. And U, the initial velocity of B, is just the final velocity after or as the string is breaking. And B is going up, so this is going to be negative 1 over 14 G. And the total distance it needs to travel is the original 1 meter plus this extra 1.175. And now what we could do is we could do S equals ut plus a half at squared. 1.175 equals, let's see if this is a 9.8 over 14 is 0.7. So that's going to be negative 0.7t plus 4.9t squared. So if I subtract this, I get a quadratic negative 0.7t plus 4.9t squared minus 1.175. And now I can stick all of this on a calculator to figure out what t is. So A is 4.9, B is negative 0.7, and C is negative 1.175. And I get t as 0.566 as the first one, and the second one is negative. So this is the amount of time it takes for B to hit the floor after the 0.5 seconds.